Hey guys, today we're going over the topic volumes and surface areas. So, these are the formulas that you're given. Most of these you'll have done in GCSE or any other syllabus you did before the IB, but just in case you haven't, I'll go over everything in this video. So this topic can get a bit tricky with the harder questions, but if you have a good fundamental basis and knowledge of the basic concepts, you should be able to solve those harder questions without too much trouble. Anyways, let's just get into an example. We'll do two easier questions, then we'll get into a bit more complicated question. So, a hemispherical ice cream cup is made of 1 millimeter thick stainless steel and has an outer diameter of 5 centimeters. Find the outer surface area of the cup in centimeters squared. Okay, so you should always sketch what you think is going on in these questions, so you can visualize what's happening. So it's a hemisphere, which is half a sphere, and it's an ice cream cup, so it's hollow. They tell you it's a cup. And if you didn't notice, it says it's 1 millimeter thick. So that measurement right there will be 1 millimeter. Okay, it also says there's a diameter of 5 centimeters. So that would be 5 centimeters. And how would we solve this? Well, I want to emphasize something before we get to solving this question. Whenever you're finding the surface area of a sphere or a hemisphere, some students get confused because a sphere is 4 pi r squared. Okay, so students assume, okay, half of that is 2 pi r squared. But this is actually wrong. That's not correct. What you have to account for is, yeah, this outer part is 2 pi r squared. But this part here is plus pi r squared. So that would be the correct formula, right? You have to account for the full thing. Okay, because a sphere doesn't have an opening like that. So you don't have to add the pi r squared, but for this one you do. Okay, so that's how you find the surface area of a hemisphere. But for this question, it's saying the outer surface area. So you don't actually have to account for that. You can just do 1/2 of 4 pi r squared because you're only talking about the outer part. But I just wanted to clarify because some students can lose marks here that you don't need to lose. Okay, so 2 pi r squared, we know the radius is 2.5 because the diameter is 5 centimeters. So you get 2 pi times 2.5 squared. And if you put that in your calculator, you should get 39.3 centimeters squared. And that's your final answer. Not too hard, as long as you don't make a silly mistake. All right, so part two of this question is saying find the volume of ice cream that the cup can hold in centimeters cubed. All right, this is a bit more tricky, but it should be pretty simple if you know what's going on. So how do you find the volume that the cup can hold? Well, that would be the volume inside this hole here. Okay, so we find this by changing the radius of of the hemisphere. It's still a hemisphere. Inside, it's still a hemisphere, the hole, but it's just a smaller hemisphere, all right? So it's surrounded by a bigger hemisphere, but it's inside. It's smaller, okay? So how do we find the radius of this hemisphere? Well, they give us the thickness of the steel of 1 millimeter, and 1 millimeter equals 0.1 centimeters. So if you have the full solid, the full ice cream cup here, the radius is 2.5. But then if you just take the radius of the hole inside here, let me take a different color, there, okay, you just take that measurement, you would minus the 0.1, okay? So you'd get 2.4 instead of 5. Okay, that's where a lot of students make a mistake. They think you don't have to minus 0.1, but you do, okay? So you have to find that volume, okay? So then you just apply the normal volume of a hemisphere, which is 1/2 times the volume of a sphere, which is given up here, 4/3 pi r cubed, which equals 2/3 pi r cubed. And our r is 2.4, so you get, sorry, 2/3 pi 2.4 cubed, which should give you 29 centimeters cubed. Alright, a bit more tricky, but should have been simple nonetheless. Alright, now we're going to move on to a more difficult example. This is actually a GCSE question because it's difficult to find an IB question that's purely just volumes and surface areas, because the IB tends to mix topics a lot. So they would do volumes plus maybe Pythagoras theorem or SOHCAHTOA or stuff like that. So just focus on volumes and surface areas on this video, I picked a GCSE question, but it's something you could definitely see in the IB. Okay, it wouldn't be worth too much, maybe 4 to 5 marks, but it's definitely worth trying this question. So you can pause the video and try yourself. It is with a calculator, because you do get a calculator in GCSE, but pause it, try yourself, and then come back and see if you got it right. Okay, so a solid shape is made by removing a hemisphere, shown shaded from a cone, as shown in the diagram. Right, so, okay, so that's the hemisphere, and they remove it from the cone, basically. That's what they're saying. So the radius of the hemisphere is 2x. The radius of the base of the cone is 5x. The vertical height of the cone is 6x. So what you want to do is just write all this down on the diagram. So this is 2x. This would be 3x, because 3x plus 2x is 5x, which is the radius of the cone. And the height of the cone is 6x. All right. So they tell us the volume is 6948 pi centimeters cubed. And we need to find the total surface area of the solid hemisphere that was removed. Okay, so not the surface area of the shape they create, which would be something like an ice cream cone with the hole inside. We don't want to find the surface area of that. We want to find the surface area of the hemisphere they removed. Okay, so of this. Okay, how do we do that? Well, first we need to find the radius. We need to find the value of x. Okay, and we do that by making an equation. So the volume of the solid shape is 694. And remember, the solid shape is this. Okay, it's the cone with the hemisphere removed. Right, that's actually wrongly drawn. It would be something like this with a hemisphere removed. Okay, and we find the volume of that by doing volume of the cone minus volume of the hemisphere, because you remove the hemisphere from the cone. Then you get volume of the solid shape. Okay, so a volume of a right cone is 1/3 pi r squared h. Volume of a hemisphere, oh, not sure what that is. Alright, whatever, I'm gonna ignore it. Okay, volume of a hemisphere is 1/2 times the volume of a sphere, which is 4/3 pi r cubed. And then you get the volume of the solid shape. Okay, so to simplify this, you get 1/3. I am going a bit slow, guys, to explain it to anyone who doesn't understand, but feel free to watch it a bit faster, so if you understand it. So 1/3 pi r squared h minus 2/3 pi r cubed. Now we sub in x for the r. So remember, these two are this r and this r are talking about two different things. This is the radius of the cone, and this is the radius of the hemisphere. Okay, they're two different values. So remember, cone and hemisphere. They're two different values of x. So in terms of x, this would be 1/3 pi, I believe it was 5x. Yeah, 5x squared times 6x, because the height is 6x, minus 2/3 pi, radius of the hemisphere is 2x cubed. Okay, now in IB you can just use nsolve because this all equals 6948 pi. You can just use nsolve and you'll get the value of x to be 5.37. Okay, I'm not going to go into how you simplify that. It's just basic algebra, which you guys should know. But either way, you can use nsolve. Okay, so once you have the value of x, you need to find the surface area of the solid hemisphere. Now, remember, in the second example, we spoke about how a solid hemisphere, the surface area is not just the outer layer, but also the top bit here. So the formula would be 2 pi r squared plus pi r squared. And since r equals 2x, you get 2 pi times 2x squared plus pi times 2x squared. And that should equal, if you sub in x as 5.37, 2 pi times 2 times 37 squared plus pi 2 times 5.37 squared. And if you put all that in your calculator, you should end up getting 1087.12, I believe, and to the nearest integer, that's 1087 centimeters squared. That should be your final answer. I hope you guys understood the lesson. If you have any questions, let me know, and I'll do my best to answer them. But that's the topic. It's not too difficult if you understand. Like, if you understood fully what's going on in these questions, you should have been able to do this question relatively easily. But if not, don't worry, keep practicing. You can get great questions from IB Docs or Revision Dojo. And other than that, I'll see you guys in the next video.